I welcome you all for the 24th session of the mechanical measurement subject, and today's topic to be discussed is proving ring. This proving ring comes under the subject or mechanical measurements, unit 3, and in the chapter measurement of force, pressure and torque. In the last session we have discussed about the spring balance. In today's session only proving ring will be discussed. In the next session strain gauge type load cell will be discussed. Before going to the proving ring, let us know something about spring balance which I have discussed in the last class. As we know that this spring balance is a device which is used for the measurement of weighing of an object. Generally in spring balance, it converts the applied force into the displacement based on the spring constant. It means it works on Hooke's law. Generally Hooke's law states that for elastic deformation of a spring, the applied force is directly proportional to the change in length. It means there is a linear relationship between the force and the displacement. And coming to the working of spring balance, one end of the spring balance is fixed and the other end carries a pan, and the object to be weighed is placed in the pan. You can see here the object to be weighed is placed in the pan, and the spring deflects depending upon the weight placed in the pan. You can see a small extension here for small weight, a large extension for the larger weight. Therefore the spring deflects depending upon the weight applied, and the pointer will move on the graduated scale. You can see here the pointer moves on the graduated scale, and this graduated scale gives the reading in terms of the applied force. This is how the spring balance works. One end of the spring is fixed and the other end carries a pan. The object to be weighed is placed in the pan. The spring deflects due to the weight of the object, and the position of the needle gives the weight of the object on the graduated or the calibrated scale. Now coming to our today's topic, proving ring, we can see various designs or shapes of the proving ring. In this type, you can see a vibrating reed with a manual micrometer wheel, whereas for showing the force applied, a dial indicator is shown here, whereas to avoid the human interference, a digital type reading can also be obtained using a proving ring. These are the various models or the designs. Now let us know the different schematic diagrams of proving ring. From the exam point of view, there may be a question on proving ring. Write a neat sketch and explain the proving ring. You can write any one of the three given schematic diagrams. This is one type, this is second type, this is the third type of schematic diagram. And generally a proving ring consists of external bosses. This and this are the external bosses. They are also known as projection lugs, and it is a circular ring is called as the proving ring. This has a rectangular cross section, and at the center it has vibrating reed and micrometer wheel. This micrometer wheel and the vibrating reed is attached to the internal bosses. These are the various three different schematic diagrams. Whichever you can write from the exam point of view. This is given just for your reference, the three different schematic diagrams. Now coming to the application of proving ring, These proving rings are generally employed for measuring compressive and tensile loads. Depending upon the force applied on the external boss, either it may be a compressive or tensile force, we can measure the compressive and tensile loads. Secondly, the proving rings are used for measuring large static loads and heavy forces in industries. This is the second application. Large static loads and heavy forces in industries. Thirdly, it is used as a standard for calibrating universal testing machine or UTM. These are the three major applications of proving ring. The first one is to measure compressive and tensile load. Secondly, to measure large static loads and heavy forces in industries. Thirdly, it is employed for calibrating universal testing machines or UTMs. And the advantage of the proving ring is that these are suitable for measurement of wide range of loads. The range of force may be from 2 kilonewton to 2 meganewton. This is the advantage of proving ring. These are employed for wide range of application, that is from 2 kilonewton to 2 meganewton. Now coming to the construction and working of proving ring. You can see here these proving rings are of circular shape. These are the circular rings of precise diameter. And if you take the cross section XX, it is rectangular in shape. You can see here it is rectangular in shape. And these proving rings are generally made up of steel alloys. Therefore, first thing you should remember, proving rings are circular rings of precise diameter. They are having rectangular cross section and they are made up of steel alloys. Then these proving rings consist of ring diameter measuring device, and these ring measuring diameter devices are provided at the center of the proving ring. Mainly the ring measuring diameter consists of this vibrating reed and the micrometer screw. These are attached to the internal bosses. This is the internal boss, this is another internal boss. Vibrating reed is connected to one internal boss and the micrometer screw is connected to the another internal boss. Now when we are going to apply the force on the external bosses, the deflection of the spring gives the applied load. Before taking the reading, we should have to observe two things. Initially, before applying the load, the vibrating reed is in rest position. We have to advance this micrometer wheel until it touches the spindle of the micrometer wheel touches the vibrating reed, and the reading is noted. That is, when F is equal to 0, that reading will be noted in the initial condition. Then when you are going to apply the load, before applying the load, this micrometer wheel should be brought down to this position. You should bring the micrometer wheel to this position before applying the load. When you are going to apply the load, once again you have to move the micrometer wheel until the spindle touches the vibrating reed, and the reading is noted using the micrometer scale. That reading gives the total load applied. Now forces are applied to the external bosses. It may be either compressive load or it may be a tensile load. These are the external bosses. Now here we have applied the compressive load. When the compressive load is applied, the ring deforms into this shape. If it is a tensile force, the ring will elongate in this shape. Here compressive load is applied. When the forces are applied to the external bosses, there is a deformation in the spring. This resulting change in diameter of a ring is measured by means of vibrating reed and the micrometer screw. After applying the force, there will be the deflection in the proving ring. The deflection in the proving ring is measured using the vibrating reed and the micrometer screw. After applying the force, the proving ring gets deflected. Then this vertical vibrating reed is set in motion by giving a gentle tap. Just to give a small gentle tap, the vibrating reed start vibrating with some frequency. Then the micrometer screw on the spindle, this is the enlarged we have shown here. This is advanced until the bottom of the spindle just contacts the vibrating reed here, until it damps out its vibration or the frequency. Initially, when you are going to apply the load, this proving ring will get deformed, and then we are going to give a gentle tap on this vibrating reed. Then this micrometer wheel, which is at the bottom position, it is moved upward until the spindle touches the vibrating reed and damps out its vibration. Then just when this micrometer spindle contacts the vibrating reed, a characteristic buzz sound is produced, and reading of the micrometer dial indicates the diameter of the ring, which is calibrated in terms of force. This is how a proving ring works. Before going to the next slide, let us see how this proving ring works. See, this video is downloaded from internet. This is conducted in some university. Initially, the initial readings are noted of the component. This is a cement concrete block of circular shape. It is placed in a fixture. It is having a bottom U-shaped frame, and the upper U-shaped frame is here. While placing in the fixture, a paper is placed between the concrete block and the U-frames. The reason is that the concrete block, when it collapses or breaks, it should not stick to the U-frames. That is why a paper sheet is placed between the U-frames and the cement block. After placing the cement block in the fixture, it is taken to either to a UTM or to a compressive testing machine, and two dial indicators are fitted, one on the fixture. The dial indicator fitted on the fixture gives the deflection of the proving ring, and the dial indicator is directly mounted to the proving ring, gives the applied force or the load. Before starting the machine, the pointer in both the dial indicators are set to 0. After setting the dial indicators to 0, the machine is started. Now you can observe the pointer moves on the dial indicator. This pointer will move until the block has capacity to take the load. Once it loses its capacity or the capability, the pointer moving will stop. As you can see here, the deflection pointer has stopped, and the applied load for indicator also has stopped. This is how how the experiment is carried out using a proving ring. Now let us summarize. Now the one important thing you can note down in proving ring is that the maximum deflection of this proving ring is of the order of 1% of the outside diameter of the ring. The maximum deflection is typically of the order of 1% of the outside diameter of the ring. This is about proving ring. Now let us summarize what type of questions will appear in the exam. The first question is define force and list any three force measuring instruments. As already we have discussed this in the last session. For defining force, I have given 4 different definitions. You can write any one of the definition. The first definition I have given is force is an agent which tends to produce or destroy the motion. The second definition I have given, it is a quantity which is capable of changing the size, shape or motion of the body. The third definition I have given, it is a reaction between two bodies, and the reaction may be either a tensile type force or it may be a compressive type of force. And the fourth definition I have given is, according to Newton's second law of motion, the force is the product of mass and acceleration. These are the 4 different definitions for force. For listing any 3 force measuring instruments, there are 3. The first one you can write it as the spring balance, which I have discussed in the last session. The second force measuring instrument may be the proving ring, which I have discussed today. And the third force measuring instrument may be strain gauge type load cell, which I are going to discuss in the tomorrow's class. This is the first question for 5 marks. 2 marks for the defining force and 3 marks for listing the any 3 force measuring instruments. Then the second question is sketch and explain the instrument commonly used for measurement of heavy loads in industries. He has indirectly asked this. It means the instrument which is used for measuring heavy loads in industries is nothing but the proving ring. And the third question he has asked is explain with neat sketch the construction of working of proving ring. Here he has directly asked to write with a neat sketch construction and working of proving ring. Now, once again let us summarize what is proving ring, how it is constructed, how it works. For writing this, the question may be from exam, it will be asked for 5 marks. First you write down the sketch for simple schematic diagram. You can get 2 marks easily. This consists of a vibrating reed. This is the proving ring. This is the vibrating reed. This is the proving ring. This is the micrometer wheel, the applied force. And this is a simple type of schematic diagram. Then you go on writing what are its application, how it is constructed and how it works. We know that this is generally employed for measuring compressive and tensile load. Then it is also used for large static and heavy forces in industries. And thirdly, it is employed for it is used as a standard for calibrating universal testing machine. Now coming to the working, these are the circular rings with rectangular cross section, and these are proving rings are made up of steel alloys. Then for measuring the deformation of the ring measuring device is placed at the center of the proving ring. And here the ring measuring device consists of vibrating reed and the micrometer wheel, which is attached to the internal bosses of the proving ring. Then when we are going to apply the force, the proving ring gets deflected or deformed, and the force applied is determined by the deflection of the proving ring. And when we are going to apply the forces, that is on the external bosses, the resulting change in diameter is measured by means of this vibrating reed and the micrometer screw. And then after applying the force, the ring will get deformed, and then we are going to give a vibrating reed a gentle torque so that it starts vibrating. Then the spindle of the micrometer will advance upwards until it damps out its vibration of the vibrating reed. When the spindle of the micrometer wheel touches the vibrating reed, a characteristic buzz sound is produced, and the reading of the dial indicator gives the force, which is it gives the force. And you should note down that the maximum deflection of the proving ring is of the order of 1% of the outside diameter of the ring. This is how the proving ring works. And also, the major advantage of this proving ring is that it is employed for measuring a wide range of force, that is ranging from 2 kilonewton to 2 meganewton. And the major disadvantage of this proving ring is that it is not suitable for repetitive measurements. Now let us know how much you have learned from this session. I have framed here some multiple choice questions. The time is 15 seconds for answering this question, otherwise the answer will appear on the screen. The first multiple choice question is that dash is used as a standard for calibrating universal testing machine. Your time starts now. 4 options are there. A. Spring balance, B. Proving ring, C. Strain gauge, D. Ring gauge. Just try to answer, otherwise the answer will appear. Yes, the answer is B. Proving ring. Proving ring is used as a standard for calibrating universal testing machine. Whereas the spring balance are employed for weighing the object, strain gauges are employed for measuring the varying loads, ring gauge is employed for checking the diameter of the external parts. Now let us go to the second question. Proving rings are normally used for force measurement within the range of, your time starts now. A. Option A 0 kilonewton to 2 kilonewton. Option B 2 kilonewton to 2 meganewton. C 2 meganewton to 4 meganewton. D 4 meganewton to 8 meganewton. Yes, the answer has appeared. The correct answer, the proving rings are employed for measurement within the range of 2 kilonewton to 2 meganewton. Then the third thing you should remember is, using proving ring we can measure, your time starts. A. Tensile force, B. Compressive force, C. Both tensile and compressive force, D. None of the above. Yes, the answer should be A, B, C, D, and the correct answer has appeared, that is both tensile and compressive force. Proving rings are employed for measuring both the tensile and compressive force. The fourth thing you should remember, the force which is applied on the proving ring is determined by measuring the dash of the steel ring. Your time starts now. A. Cross sectional area, B. Thickness, C. Width, D. Deflection. Yes, the correct answer should be A, B, C, D. Yeah, the correct answer should be, it has appeared, that is the deflection of the steel ring. The force which you are going to apply on the proving ring is determined by measuring the deflection of the steel ring is the correct answer. Let us go to the next question. Proving rings are circular rings with, here he has asked about the different types of cross section. Your time starts now. Try to answer. A. Rectangular cross section, B. Circular cross section, C. Square cross section, D. All of the above. Proving rings are circular rings with, yes, the correct answer should be, it has appeared, that is A. Rectangular cross section. Now let us go to the next question. Maximum deflection is typically of the order of dash of the outside diameter of the ring. Your time starts now. Option A 0.01%, B 0.1%, C 1%, D 10%. Yes, the correct answer has appeared, that is C, that is 1%. 1% is the correct answer, that is maximum reflection is typically of the order of 1% of the outside diameter of the ring. These are the references. Team members. I hope you have enjoyed this section. In the next session, I am going to continue with strain gauge type load cell. Until that, thank you.